All right, ladies and gentlemen, and welcome back to this Athenian Stranger tutorial video, where today we're going to learn about systems of equations. Systems of equations are really just two different lines graphed on the same coordinate plane, and we're going to see where those lines intersect. We'll start with a warm-up. The reason these warm-up problems look the way they do is because we have to become very flexible in how we solve equations. With systems of equations, sometimes you're solving for x, sometimes you're solving for y. So it becomes important that we have kind of a flexibility when it comes to what we're looking for. Let's take a look at warm-up problem 1. Here we are asked to solve for x. We're not asked to find the x-intercept. We're just asked to get x by itself, preserving y. Okay, so I don't want to get rid of y. I just want to solve for x. Let me show you what that looks like. It's easier than it looks. We just add 6 to both sides. Okay, and negative 6 plus 6 is 0. And over here, I can't mix 6 and y together. So I just say y plus 6. Okay, y plus 6 equals 3x. Now I've got to get rid of the 3. It might be tempting to divide 3 here and then divide the 6 by 3, but don't forget, I've also got to divide the y by 3 as well. So if I go through here and divide each of my terms by 3, I'll accomplish my goal of getting rid of the 3's. I can cancel them on the right side of the equation. But now I've got this y over 3. What is that? Well, a little bit of side work here. Y over 3 equals 1/3 y. What I can do is, there's actually a 1 multiplied by that y. And what we're able to do is kind of pull the 1/3 out. So I could say 1/3 times y. And I could always multiply that 1/3 back into the y and get y over 3. But it's not very useful to write y over 3. It's more useful to write 1/3 y. So we'll write 1/3 y plus, and now I have 6 over 3. Well, 6 over 3 is just 2. 6 divided by 3 is 2. So 1/3 y plus 2 equals x. And now you've solved this equation for x. There's nothing else to do. Okay, take a look at number 2. In number 2, see, in number 1 we were asked to solve for x. In number 2 we're asked to solve for y. Again, we're trying to reinforce our flexibility with what we solve for. There's no specific process to memorize. We just have to use our algebraic techniques to move terms around until we get the letter we want. So if I want to get y by itself in this problem, I need to move this x term over to the other side of the equation. Well, right now 2x is being added to 3y. So because it's positive 2x, I'll subtract 2x from the left side of the equation, like that. And I'll also subtract 2x from the right side of the equation. When I subtract 2x from 2x, on the left side I get 0. And on the right side, I can't mix the terms, all right? So I can't combine 9 and negative 2x in any way. They just have to kind of sit next to one another. So all that remains on the left side of the equation is 3y. (3y) equals negative 2x plus 9. Remember, we kind of want to think about y equals mx plus b. This is the slope-intercept equation of a line. Y equals mx plus b. I want this term with the x to be up front next to the equal sign. So I don't want to write 9 minus 2x because then the mx part would be at the end. I want to think about kind of how line equations look and put that negative 2x term up front. Negative 2x plus 9. Okay, so far so good. Now I need to get rid of this 3. Right now, the 3 is being multiplied by y. So to get rid of it, I'll divide each of the terms in my equation by the y coefficient. Remember, this number in front of the y is called the coefficient. So I'll divide by 3 for each term. Okay? That allows me to cancel the 3's in front of the y. And now I get y equals. Now look at this term here. I've got negative 2 over 3x. So negative 2/3 x. Plus 9 over 3. Well, that can be reduced to just 3. 9 divided by 3 is 3. Plus 3. So now I've solved for y. This looks like the equation of a line in y equals mx plus b form. Where m would be negative 2/3 and b would be 3. So I could graph that line if I wanted to. And let's put that in a box. I want to skip the warm-up problems 3, 4, 5, and 6 because I want to make sure this lesson stays focused. We don't spend the entire time on the warm-up. Let's look down here because this is really going to prepare us for the lesson today. Look at problem number 7. It asks us to graph 3x plus 4y equals 4. Well, first thing to do is write it again. So we have some space to work. 3x plus 4y equals 4. Okay, so when you're asked to graph an equation, you want to get it in terms of y. So you want y by itself on the left, and then you want the rest of it in mx plus b form. So here I'll move the 3x by subtracting 3x from both sides. Okay, so 3x minus 3x is 0. And over here, I can't mix these two terms. They're not like terms. It's not 4 minus 3 is 1, and then you can't do anything. These are apples and oranges. 4 is an apple, negative 3x is an orange. 4 is oil, negative 3x is water. They don't mix. So here I've got 4y. And 4y equals negative 3x plus 4. All right. Now what I'd like to do is get y by itself. So I will divide through each of my terms, okay, by 4. That allows me to cancel out the 4's on the left, and it leaves y by itself. Y equals negative 3/4 x plus 4 divided by 4 is 1. What I've got here is an equation in slope-intercept form. Y equals mx plus b. Take a moment to think about what the slope is, what the rise over run is, and also what the y-intercept is. Okay, so for this problem, the slope m equals negative 3/4. And the y-intercept b is just 1. And that's what I need to know in order to graph the equation. Remember, a slope of negative 3/4 means that the rise, or in this case the fall, this would be the vertical movement, is negative 3, and the run, or the horizontal movement, is 4. Okay, so I'll go wherever I plot the y-intercept, I'll start from there and go down 3, and then to the right 4. Alrighty, so we'll start by plotting our point. Guess I'll do it in red at the y-intercept. Okay, so that's at 1. So I'm looking for 1 on the y-axis. I plotted it, and now I use my rise over run, or my fall over run. So here I'm going to go down 3 squares and then over 4 squares. Down 1, start at the y-intercept. Put your pen on the y-intercept and go down 1, 2, 3. Okay? And now move to the right 4. 1, 2, 3, 4. Put you a dot there. we're going to end up with a negative slope because we're going down. Okay, so we put our pen or our protractor right there, making a straight edge, going through both points, and draw a line. There it is. Okay. And for the warm-up, I'll stop there. So in class, we'll do, as a warm-up, numbers 1, 2, and 7. Okay, so that's the warm-up. And now on to the lesson, okay? So I said we were going to learn how to solve a system of equations, and I kind of showed you using my fingers that means we want to find out where two equations cross. But let's talk more in depth. What is a system in math? Well, it's just a word. Just a word. It's nothing scary. Basically, a system is just what we call more than one equation. All right, so maybe we could say 2 or more right here. 2 or more. Okay. Basically, a system is just what we call 2 or more equations. Okay. Well, what does a system look like? You can have written systems and you can have picture systems. And there's multiple ways to write systems. This is just one of them. Here's one that says y equals x plus 3 and y equals 6x minus 2. Okay, so 2 lines. And over here it says, here is a picture of the same system. Well, how is that possible? Well, all I did was graph this line, y equals x plus 3. Okay, so that was this line right here. Let me highlight this for you. This is the pink line here. Y equals x plus 3. Okay? And then the second equation says y equals 6x minus 2. All I did was I graphed that line on the same coordinate plane. This will be my green. Six x plus 2. So this has a really steep slope of 6. So if I have to identify it, I'm looking for the more vertical looking slope. And that's this one right here. Okay? So you've got 2 lines, and you see they cross one another. They cross right there. And this point where they cross, this is really, really important. Okay, this is called the solution. Where they meet, that's the solution to the system. The system is just the 2 different lines, and they have a solution if they cross. Okay, so they cross right here, and we have to find the coordinates of that intersection point. This is called the intersection. So what are the coordinates of that point? It's hard to see on this little picture of the camera, but that's 1, 4. So here I would write 1 for the x value and 4 for the y value. Look inside this box here. The, quote, solution of the system is just where the lines, and here you could say cross, right? But we would prefer you use the math term, just where the lines intersect. Intersect. Well, we already know what the solution is. It's here that says the solution of this system is, and then you have a coordinate pair. 1, 4. That's where they intersect. Use blue, shows up better. 1, 4. And this is how you say, see, you can already do this. It's easy. If you can graph one line, you could graph 100 lines on the same coordinate plane. And here we're graphing just 2 lines. So let's go through the process again. You'll probably be given 2 equations, or you'll create them. Then you graph them, and then you write down where the lines intersect. This is the graphical method of solving a system of equations. There's multiple other methods, but this is the first one that you'll learn. Okay? Look in this box right here. The solution of a system will always be a blank. And then x comma y is over. We call x comma y a coordinate pair. We're always looking for 2 coordinates, an x and a y. So we call that a coordinate pair. And my hand's in the way, but I'll move it. I'm just writing down coordinate pair. This is one of the perils of being a left-handed person making a video. Somebody had told me I was going to end up making math videos on YouTube. I would have tried to learn how to write right-handed when I was 3 or 4 years old. Okay, so now we've got our feet wet on this. Let's keep going. We need to learn a couple more things. Let's see if I can fit all this in here. Maybe, maybe not. Okay. So there's these 2 special cases. Got to talk about these. Some systems have no solution. Okay? No solution. That's what I'm writing as I cover up the camera. Some systems have no solution. Okay, let's see what that might look like before we talk about the why. Here I've got 2 equations. These are both in slope-intercept form, so I can graph. Thumbs up on that. I need to identify the slope and the y-intercept of each of these. And this might not be obvious because we're just getting started with this. Remember, when you have x by itself, just hanging out there, the m that sits in front of the x, y equals mx plus b, the m is 1. Okay, so this is 1 here. And I'm going to call this my blue equation. And then down here, I'll put this one in red so you can keep it distinct in your mind. For my red equation, the m is also 1. Okay, so those slopes are the same. So for the first equation, m is 1. And b, remember y equals mx plus b, b is 1, the y-intercept. Remember, b is the y-intercept. So b is 1. So what am I saying? I'm saying this thing hits the y-axis at 1, and then it goes up 1 and over 1. Rise 1, run 1. Rise 1, run 1. For my red equation, m equals 1. And b equals 3. Well, now I need to graph them. Let's graph them and see what happens. So let's graph the blue equation first. My y-intercept is 1, so my pen will instantly and naturally go to the y-axis and park itself right here at 1. Now, in order to plot that second point, I have to use rise over run. Well, that's 1 over 1. So I go up 1 over 1. Okay, there's a point. I could also go down 1 and to the left 1, because that's just the reverse. And you see the pattern emerging here, right? It's just going to be like this. You could fill in the whole line if you wanted to. Let's connect all those dots. Looks about right. I should tell you why I'm taking so much time with putting the protractor up here. You see these little lines, this grid in the background? Where these lines intersect, okay, where the boxes all touch, like right there, right there, right there, those are called lattice points, L-A-T-T-I-C-E, lattice. And those lattice points are where I'm trying to make sure my protractor is lined up with. Otherwise, I'll graph the line kind of off. It won't make a big deal, but it could change value, so just want to make sure I'm being real precise. You see how the line that I just drew in passes through each lattice point? Okay, that's important. Okay, so for my red line, I'll start at a y-intercept of 3. So I'm just going back in here, I'm looking on the y-axis for 3. And that would be right here between 2 and 4. Let's put that y-intercept in. And now let's graph. Here we have a slope of 1. So I go up 1 over 1, up 1 over 1. Okay. Like that. Ready to plot it in. Okay, so there's my second line. And I'm saying that this has no solutions. Well, why is that? From a visual perspective, it looks like these lines are parallel to one another. And parallel lines never cross. So down under why no solution? Right? The big one is the lines are parallel. I'm just writing parallel lines. All right? So right away there, parallel lines have no solution. That's the big rule. But if you didn't have a graph, how would you know they were parallel? Well, parallel lines have the same slope and different y-intercepts. So here's like the definition of parallel lines. Same slope, different y-intercept. What I'm writing is different y-int. Okay? Number 4 is kind of a reiteration of number 1. The effect of parallel lines is that they, or the lines, never intersect. They never cross. And I'm writing never intersect. The lines never intersect. Remember, the definition of a solution to a system is the intersection point. So if there is no intersection point, there is no solution. If there is no intersection anywhere, there is no solution. And parallel lines will never intersect, therefore, this system of two lines has no solution. Okay? So if you're still writing that down, people who are ahead can start taking a look over here. And I'll just let you know that this one's going to say some systems have infinite solutions. Let me just write that and then I'll move my hand. Infinite solutions. Okay? Take a look at these lines here. You're going to have to do something to the second equation. Okay? So this top equation, I'll be my blue equation. All right? What's the slope of the blue equation? Y equals mx plus b, where m is the slope and b is the y-intercept. The slope, m, equals 2. Okay? That means we rise 2 and then we run 1. What's the y-intercept of the blue equation? The y-intercept b is 1. Okay, the second equation, I actually have to do a little bit of surgery on it before it's ready for prime time. I need y by itself. All right, so just one step, we'll get y by itself. This will be my red equation, so I'll do this in red. How would I get y by itself? I have to add 1 to both sides. On the left side of the equation, -1 plus 1 is just 0. And on the right side of the equation, I can't mix those at all, so it's 2x plus 1. So now y equals 2x plus 1. Y equals 2x plus 1. So m equals 2 and b equals 1. Let's graph these lines. So first I'll graph the blue equation. I have a y-intercept at 1 and a slope of 2. So I start at my y-intercept and I go up 2 over 1. Up 2 over 1. Let's now graph in this line. Okay, so that's the blue line. Now let's graph the red line. I have a y-intercept of 1. So I go bubble in at 1. Oh, look, I'm bubbling in right on top of my other y-intercept. And now I go up 2 over 1. Bubble in there. Up 2 over 1. Oh, I keep putting the points right over the blue points. Well, now when I sketch in my line, I'm drawing right over the blue line. You can barely even see that there's 2. What's going on here, right? That's kind of the question. Well, look at the equations. Look at this equation. Y equals 2x plus 1. Look at the red equation. Y equals 2x plus 1. Right? They're the same line. Okay? So why are there infinite solutions? We can write something like the lines or the equations. I'm gonna move my hand. The equations are the same. Okay, but why are they the same? If you had to just look at the equations themselves, what would you tell me about their slopes and their y-intercepts? You'd say slopes and y-ints the same. So we have the same slopes and the same y-intercepts. So because the lines are identical, when we graph them, they're sitting right on top of each other. And so we could say, somebody said this in class and I liked the way they said it. They are the lines. Okay, the lines touch everywhere. You know, we could say that they intersect everywhere. They're touching every single place. So they have an infinite number of places that they touch. Therefore, they have infinite solutions. So those are the two special cases. No solution and infinite solutions. So you'll run into this one quite a bit on the STAR test. You'll run into this one quite a bit in your homework. If you see this one, it would be more obvious because the equations would be the same. So for no solution, you've got the same slope, different y-intercepts. That's the definition of a parallel line. For infinite solutions, you'll have to have the same equation, or the graph, for the graphs to look like that. Okay, I'll do one of these practice problems here with you, and then we'll call it a day on the video. Solve each system by graphing. Okay. Let's look at this first pair of equations here. Remember, all we're going to do is graph each line and see where they cross, or if they cross. So this top one, I'll make this my blue. Here, y equals mx plus b, so m is -5. And b is +2. For my red equation, remember there's in front of that x, there's a 1. So m is 1. B would be -4, okay, because it's x minus 4. So b is -4. Well, are these going to be parallel or identical? No. Different slopes, different y-intercepts. They're definitely going to cross somewhere. Well, let's just plot them in. So I start at the y-intercept of 2. Remember, on the y-axis, I find 2 and I put a dot. And now I have a slope of -5. So it's a negative slope. That means I go down 5 points and over 1 point. Down 5, 1, 2, 3, 4, 5, over 1. Okay, so there's a point right there. Now I can take my protractor. It's going to be real important that I make sure those lattice points are lined up. You got to kind of play with it a little bit. Now drawing your line. Take your time with this. That's line blue line, top equation. Here's the second equation in red. My slope is at -4. So I go on the y-axis to -4. And I have my slope. My y-intercept is -4. So I go to -4 on the y-axis, and then I have a slope of 1. And I go up 1 over 1, right? Look where my pen is. See that? It's right on that blue line. And let's start there and go up 1 over 1 again. Up 1 over 1. Okay, so this is the, I'm going to connect all those dots now. Be real careful. Make sure those little gray lines in the background, that you're going right through the intersection of those lines. Okay? Cool. So we see where they're crossing. The solution to the system is just the coordinates of where they cross. All right, so what are the coordinates right here? One on the x, -3 on the y. It doesn't get any harder than that. I mean, sometimes the equations are not in slope-intercept form, so you'd have to put them in slope-intercept form by manipulating them a little bit and then graphing, but that's how you would do number 2, same way you did number 1. And I recommend you write this out. Write it down M, write down B. Use different colors so you can help distinguish them. Okay, you've got these practice problems here. I've got some more practice problems on this page here. And then for your homework assignment, where did that go? Here we go. For your homework assignment, you see it's just the same thing. So you're just going to be doing this on CUDA, but I've given you an actual physical piece of paper so you can perform the graphing. And then you would just tell me what the solution is on CUDA. Okay. All right. Well, good job today. This is a big topic. It's one that will take us a few class periods to understand. But I hope you got your feet wet here. Just remember that a system is going to be 2 or more lines. We're looking for the intersection point of the system, and today we learned how to do it graphically. Okay? So I hope this video was helpful to you. If it was, please like the video. Make sure that you're watching these videos because where I show you how to do all this stuff. If you have not already, make sure you subscribe to the channel and hit that notification bell so you're always updated when I release new videos. Thank you.